Okay students, in last video about combination of resistance, you saw about series connection. I hope that topic is clear to you. Now we will move towards parallel connection. Parallel connection. In last video I gave you the briefing about what is parallel connection and what is series connection. Then we move forward in it and we found the equivalent resistance for series connection. So we will revise what is parallel connection once again, and here also we will find out the equivalent resistance. So let's move towards our topic, that is parallel connection. So what is parallel connection? In between two points, n numbers of resistances can be connected. How? The start and the end should be common. If you take multiple ways and if all the ways are meeting after and before at the same point, but in between they have been divided, then this kind of thing is known as parallel. So here in parallel connection, the resistances are connected in such a way that they have one common start point and one common end. Okay, so to this, if I apply a battery of, let's say, volt V, if I am applying a battery of volt V, some amount of current I will flow. Let's name this resistance for our convenience as R1, R2 and R3. So this current will come till this point where all the resistance are getting splitted up or divided. So at that point we termed it as A. After coming here, the current is going to get divided across all the three resistance. So current I1 will flow through R1, I2 current will flow across R2 and I3 current will flow across R3, and after coming out, these three currents will get added up and again it will come together, and the total current I you will get, and it will flow through your circuit. This I told you in your earlier lecture also. I am just revising this topic once again. So here you have three resistances, right? It can be more or it can be less, but more than two. So you have three resistances. Now equivalent resistance of this three, that is, if you replace this three resistance with a single resistance, then what kind of circuit you will get? You will get something this kind of circuit with a single resistance, and the battery will have the same value V, and the same amount of current should also flow through the circuit. So these three resistance will get replaced by a single resistance, and that resistance is nothing but your Rp. That is your equivalent resistance for this circuit. So now we will find out how to get this value, how to get the value for Rp, that is equivalent value of the resistance. So let's find out the equivalent value for the circuit. So let's do it once again. Let us take three resistance, R1, R2 and R3, and connect them with a power supply of volt V. And let us connect it with a power supply of volt V. We did that. We connected it with the power supply of volt V. Okay. Now, what current is going to flow through the circuit? I amount of current. So here, at least for now, your I amount of current is flowing through the circuit. So first we will look towards the potential, then we will move towards the current. So the potential drop between A and B, that is across your parallel combination, is going to be what? It is going to be V. It is going to be V. Your potential difference across this resistance or this combination is V, and that is going to be same for your R1, R2 and R3 because it is the difference between these 2 points. So it is going to be V. So your potential for all the resistances same. In series connection, your current was same. In parallel connection, your voltage is same for all the 3 resistance. Now what about current? Current will come at point A. Or at A terminal it will come and it will get divided into I1, I2 and I3. That is I1 current from R1, I2 current from R2 and I3 current from R3. Right? And it will get combined and it will, at point B it will get combined and it will flow through the, I amount of current will flow through the circuit. Right? So we know that this. Now we will find out the equivalent resistance. So what happens? Your I amount of current is getting divided into 3. That is I1 plus I2 plus your I3. It is getting divided into I1 plus I2 plus I3. So now we will apply Ohm's law across R1, R2 and R3. So what does the Ohm's law says? Ohm's law says V equals to IR. So for I it is going to be I equals to V by R. Right? Since we are talking about current, I rearranged the terms of Ohm's law such that I will get it in the terms of I. So my current I equals to V by R. So for R1, what is the current flowing through R1? That is I1. I1 current is flowing. What is the voltage? Voltage is same. So V by R1. For R2, what is that? I2 equals to V by R2. For R3, what is that? I3 equals to V by R3. Students, please keep noting down these things. Okay. Now I have told you the equivalent resistance is a resistance which will have the equal value of all these 3 resistance and same amount of current will flow if we replace this combination. So what I told, what that resistance is going to be? Rp. So we need to find out current through that also. And that current, what I said, it is going to be same. That is going to be I. So my I current is going to flow from Rp. So for Rp, my I current is going to flow. Voltage is going to be same. And that's it. Now we will keep all this value of I, I1, I2, I3 in our equation. Which equation? I equals to I1 plus I2 plus I3. So note this down. Pause your video, note it down. Okay? I hope you have noted it. Now, instead of I, what I am going to keep? V by Rp. Instead of I, what was that? V by R1. Instead of I2, V by R2 plus V by R3 for I3. Right. Now see, here you can see V. V is common. We can take it out. Yes, but obviously we can take it out, right? V by Rp is equals to V in the bracket 1 upon R1 plus 1 upon R2 plus 1 upon R3. Right? Here and here. On left hand side and right hand side you have V. So we can cancel it out. So you are left with what? 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. And this is nothing but your equivalent resistance for parallel connections. Parallel connection, right? Now since we were talking about only 3 resistances, here we have 1 upon R1 plus 1 upon R2 plus 1 upon R3. What if there are n number of resistance? No problem. You can just add them. How many number of resistances are there? You can just add their reciprocal. That is 1 upon R4, 1 upon R5, such that 1 upon Rn. And you can find out the equivalent resistance for your given parallel combination. I hope you are clear with this topic. Let's give a quick recap towards this. What is that? In parallel connection, your resistances are connected such a way they start from one single point and they end at one single point. All the ends are connected to one point and the second end of the resistance is connected to another point. Your voltage is same across all the resistance, but your current is divided. Your voltage is same, but your current is divided. That you can see from here. Now for individual resistance, that is R1, R2, R3, we found out the current with the help of Ohm's law. What was that? V by R1 plus V by R2 plus V by R3. Then we kept it in our equation, that is I equals to I1 plus I2 plus I3. Then we took out V because it was same for all the resistance. We cancel it out and then we are left with 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So in this way you can find out your equivalent resistance for parallel combination. Equivalent resistance means a single resistance which will show the same value of current and voltage when we replace a combination of resistance with a single resistance. Okay? I hope now you're clear with this topic also.